7.1 Functions and Mapping Diagrams Notes. So, a function. A function, it has given an input, there's an operation that happens to it, and it kicks out an output. So, have you ever been to a museum and you've had like those penny machines where you put a penny in and it does something to it? Well, that penny that you put in is your input. So you're inputting the penny into that machine, and sometimes you can see what's happening in it, sometimes you can't, but it's going to do something to it. And then out comes a flattened penny with, say, the Museum of Fine Arts on it or something. And so this is our output. That flattened penny is with an imprinted something which the machine has done an operation to. Operation, or what we call in math, the function. So that, whatever that operation is that happens to it, is the function. So the input is put into the function, and then output happens. So in math, we usually use x as our input. So let's say our input was 2. Well, that's going to go into an operation. And let's say our operation, our machine, is y equals x plus 3. Well, if we put a 2 in there for x, because that's what we inputted, 2 plus 3 is, our output then is y equals 5. And so that's our output given our input of 2 with our function in the middle. So our functions can be written as mapping diagrams. So given, say, some coordinate pairs, 7, 0, 4, 2, 3, 5, and 1, 5. We can make a mapping diagram. So our mapping diagram is a group of inputs. So we'll list that inputs here. And our outputs, a list of our outputs. So now what we're going to do is take our coordinate pairs and put them in. So I notice that I have a 7, a 4 for my input. So I've got a 7 for my input, a 4 for my input, a 3 for my input, and a 1 for my input. Now my outputs are over here, the y's. So I have a 0, a 1, a 5, and a 5. So when we put them in, though, we only put in a 0, 2, and a 5 because the outputs are just the numbers that we have. So even though it's 5 twice up here because it's in a coordinate pair, in our group we only need to have 1 because that 7 maps to 0. So I'm going to draw an arrow, and it has to be an arrow. So that's that mapping of 7 to 0. Now the 4 maps to 2. So 4 maps to 2. Then 3 maps to 5. And here's where why we don't need a double is because the 1 up there also maps to 5. So we'll just draw the arrow to 5. So 3 and 1 map to 5. And this right here is a mapping diagram. So in algebra, when we get a little bit more complex, we also call that a domain is the input, and the output is called the range. Those are two other names that we can use for those. So now if we take a look at another example, that 3, let's be given a mapping diagram. So we have our inputs and our outputs. And in our inputs, say we have a 3, a 2, and a 4. Our outputs, we have a 6, 1, and 8. So make sure that we put a circle around those because that is a group of numbers in the inputs. And here is our group of numbers of outputs. So now we're going to map our numbers. So our arrow is going to go from 3 to 1. So our 3 maps to 1. Negative, oh, it's a -2. Wow, I missed my negative. Ooh, goodness. So let's put a negative in there. So that -2 maps to 6. And the -2 maps to 8. The 4 will map to 1. So there's a lot of crisscrossing, but what we can do is we can think about these as coordinate pairs also. So we're kind of working the other way. So 3 we said maps to 1 for the coordinate pair. -2 first maps to 6, but then also goes back and maps to -2 maps to 8. And then lastly, 4 maps to the 1. Now, we can write these in both ways. We could even take this and graph it. So we could take that mapping diagram and we could create a coordinate pairs. We could also make a table, and that's kind of how I structured this one, X and Y, or input and output if you want to put in there. We could do 3, 1, -2, 6, -2, 8, and 4, 1. So that's how a table would look from that mapping diagram. We could take this mapping diagram and make a graph of that also. And really, if you have a hard time going from the mapping diagram to the graph, you can write the coordinate pairs first and then graph them. And so let's graph that 3. If we go over 3, so 1, 2, 3 would be here, goes up 1. So I'll put that 1 right there. That's that point for that mapping of the kind of the red black one. 3 maps to 1. So now we have -2. So I'll make -2 here. And -2 maps to 6. So let's put 6 up here. That would be that point there. -2 also maps to 8. Oh, so there's another one above that at 8. So -2, 8. That's where that point is mapped in the mapping diagram. And 4 +1. So over 4, up 1 would map on a graph. So that's changing the different formats of our mapping diagram.